All right, fellas, ladies and gents, let's go ahead and get started on this. This assignment is due tonight. So this is chapter 5.5, first part of it. And today we're talking about double angle formulas. All right, so this one starts off, and we already did number 4 in class, right? So your homework, your assignment was, let's see, this is 5.5, part 1, page 382, numbers 1 through 4, 11 through 13, and 23 to 26. All right, and I know we did number 4 in class and we did number 13 in class already. Right, so gotta look at numbers 1, 2, and 3. So numbers 1, right, and all the stuff we're doing is based off of this triangle, and I actually helped you guys draw this triangle in class already. Right, so this triangle starts off with something like this. Right triangle, 90 degree. We're talking about this angle over here. And so far, you know that this is 4 and this is 5. And then in class, sorry, that's not 5. That's 3. Then in class, we figured out that this was 5. Right? And I told you guys you need to use the SOHCAHTOA. So number 1, we need to figure out what sine of theta is. Okay. The sine of theta is the opposite of the hypotenuse. So the sine of theta is the opposite. Is going to be, so opposite of the angle is going to be across from it. So it's going to be 3. The hypotenuse is the 5, which we found. And that's the answer for number 1. So fast and easy that is. So answer. And number 2. I'll do it right here. 2, we're looking for the cosine of theta. And then using the SOHCAHTOA, this time we're doing cosine. So we're going to do adjacent over the hypotenuse. Right. And earlier when we did the sine opposite of our hypotenuse, we used this. Right, so this time around, number 2, we're using the cosine, which is adjacent over the hypotenuse. And again, the adjacent is going to be the side that's right next to the angle. So if we're at the angle here, side right next to it is going to be right here. So 4 over the hypotenuse, and that's what we found was the 5. So cosine theta is 4 over 5. That's all it is. And number 3, right? Because we did number 4 already. I'm not going to do number 4, but number 3 is the cosine of 2 theta. And now cosine, remember when the way we talked about it in class is cosine, a double angle cosine comes in 3 different flavors, right? You got the one with the cosine and the sines both squared. You have the one where it's just cosine squared, and you have the one with just sine squared. Okay, I'm going to go ahead and use both the cosine and the sine. So I'm going to use the first one. So this is, so cosine 2 theta is equal to, and we're using the double angle formula. We're going to have cosine squared theta minus sine squared theta. Right? And what that makes is cosine squared theta is just cosine of theta squared. Minus sine squared theta is just a sine of theta squared. And we know cosine of theta, we found in number 2. Cosine of theta is 4 over 5. So that's going to be 4 over 5 squared. And we know sine of theta, which we found in number 1, is 3 out of 5, or 3 over 5. So it's going to be 3 over 5 squared. So this is going to give me 16, because that's 4 squared over 25, minus 9, because that's 3 squared over 25. And 16 minus 9 is 7 over 25. Okay? And that is cosine of 2 theta. Okay, so that's 1, 2, 3, 4, right? So we did all of those already. Okay, 11, 12, and 13. So we're going to do 11. So 11 says use a graphing utility to approximate the solution, right, between 0 and 2 pi and find the exact solutions algebraically, right? So 11 is 4. So we're just solving the equation. Sine x cosine x equals 1. Right, I'm going to go ahead and write this right here as a double angle. So I'm going to write this as 2 times 2 sine x cosine x equals 1. And I know, and you know, if you look at your double angle formula for the sine, it's going to be sine 2x equals 2 sine x cosine x. Right? And that's what we have right here. We have 2 sine x cosine x. Right? And we can rewrite that as sine of x, or excuse me, sine of 2x. Okay. So instead of writing it as 2 sine x cosine x, I'm going to write that as sine 2x equals 1. Okay. And by doing this, I can now divide it by 2, and I will get a sine 2x equals 1/2. This is utilizing that double angle, or the double angle, yeah, right? So we want to find out where the answer between 0 and 2 pi is. Right. So with that one, we're going to rewrite this. So remember, it's between 0 and 2 pi, but we're going to rewrite it as an inequality. That's going to be 0 x 2 pi. And what we want is we want to find out two x, right? So if we do this, we will get 0, 2x, 4 pi, right? So we need to look at 2 unit circles. Okay. So if I solve this, yeah, I would say, okay, well, 2x, right? Sine of what equals 1/2, right? So sine of what equals half. And on your unit circle, the first round, you would get the answer of what? Pi over 6. And you will also get the answer of what? 5 pi over 6. So I'm going to move this up a little bit. Okay. But that's only the first round, right? The second round, you would get 13 pi over 6 if you look at your second unit circle. And you get 17 pi over 6. Okay. And then to find out your x, right? Because remember, we still want to find out our answer between that lives between 0 and 2 pi. We're just doing this from 0 to 4 pi just to help us with the 2x. But now that we've got it, okay, we still want it between 0 and 2 pi, which means that we still need to figure this out. And we need to divide it by 2, or we can say multiply by 1/2. So multiply by 1/2, multiply by 1/2, 1/2, and 1/2. So we can actually get x equals pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. Okay, that's number 11. 12 says sine of 2x sine of x equals cosine of x. Ooh, this one looks like quite a bit, right? And we still want to find the answer between 0 and 2 pi. Right, so I'm thinking, you know what? I'm going to use this double angle formula that I have down right here. So I'm going to use that right here. So you see it right here, sine of 2x right there. Sine of 2x. Okay. I'm going to rewrite that as 2 sine of x cosine x. So instead of writing sine of 2x, I'm going to write it as 2 sine of x cosine of x times sine of x equals cosine of x. Ooh, that looks like a lot. Okay, I'm going to combine because this is all on one side and they're all multiplication. So that's going to be 2 sine square x cosine x equals cosine of x. All right, I'm going to go ahead and move this cosine of x on this side over. And it's going to subtract over here, but it won't subtract here. Okay, you cannot cancel right here. It will cancel here, so you will have a 0. But on the left-hand side, you will have 2 sine squared x cosine x, and then since you can't subtract, you're going to have another minus cosine x sitting right there. Okay, and from here, we are going to factor out a cosine of x outside. Okay, so we will have a parentheses equals 0. And if we factor a cosine of x out, we will be left with 2 sine squared x minus 1. And if we look at this, we now have two factors. We have a cosine x equals 0, and you will have a 2 sine squared x minus 1 equals 0. You're going to have to solve them separately. So look in unit circle. When is the cosine equal to 0? My cosine is the x value, and it's only equal to 0 when x is equal to, and this is just a single angle, so we can just, whatever answer we get for x, that's our answer. It's going to be equal to pi over 2, or 90 degrees. And it will also be equal to 3 pi over 2. Okay, or 270 degrees. Okay, second one, you're going to solve this equation, add 1. And then you're going to go ahead and keep solving it, divided by 2. So you will have sine square x equals 1 over 2. And you get a square root, so you will get sine x, no square, sine of x equals plus or minus radical 1 over 2. And radical 1 is just 1, and radical 2 is just radical 2, right? And because we're looking for a sine, we need to operate this with a nicer way of doing it, looking at it. So we need to multiply this by radical 2 and radical 2. So your final answer, plus or minus 1 times radical 2 on top is a radical 2. And radical 2 times radical 2 on the bottom is a radical 4, which is just 2. So I'm looking for a positive or negative radical 2 over 2. And that's going to happen when x equals. All right, so look on a unit circle. So when is the sine? Sine is a y, positive or negative radical 2 over 2. So you will get, sorry, a little more space, pi over 4, or 45 degrees, 3 pi over 4, or 135 degrees, 5 pi over 4, or 225 degrees, and lastly 7 pi over 4, or 315 degrees, right? So your answers are all of these right here. You have all of these along with all of these. So you have a total of 6 answers. Okay, we don't need to look at double or triple unit circles because this one is just reliant on these two equations, and these are single angles right here and right here. So I don't need to do a double or a triple unit circle. Okay, so that's 11 and 12, and then we did 13 in class. So not gonna worry about that. Okay, and then we didn't do 23, 24, 25, or 26. So we'll look at that. So 23. 23 is, it says, use the double angle formula to rewrite the expression. Right, so 23 is 8 sine x cosine x. And I did something similar to this earlier. Right, so I'm going to rewrite this as 4 times 2 sine x cosine x. And if you see this, right, this is a trig identity, or this is a double angle identity. We're going to use the sine, right? The sine 2x equals 2 sine x cosine x, and we're going to utilize this part right here, and we're going to turn it into this part. So answer is going to be 4, and then the 2 sine x cosine x right here is now going to be known as sine of 2x. So my answer is 4 times sine 2x. So my final answer, 4 sine 2x. That's it. Okay. 24. We have 4 sine x cosine x plus 1. Okay, and again, we're going to use the same identity right here. Maybe I should have done it like this. Okay, so instead of 2 sine x cosine x, and I'm going to write this as 2 times 2, because that makes 4 sine x cosine x plus 1. I'm going to go ahead and instead of writing this down, I'm going to write it down as this one right here. 2, or excuse me. So instead of writing it like this, I'm going to write it like this. Okay, so this, I will have 2 sine 2x plus 1, and then my final answer, 2 sine of x, or 2 sine of 2x plus 1. Okay, that was 24. 25. Get 6 minus 12 sine squared x. Okay, and I'm going to use the same kind of idea. I'm going to go ahead and I'm not going to use the double angle for the sine anymore. So I'm not pulling this guy down. Okay, I'm not using this anymore. So I'm not pulling him down. This one, I'm going to use the cosine. So double angle for cosine. So first, I'm going to go ahead and factor out a 6. So take a 6 out of both of those terms. So if I take a 6 out, right, if I take a 6 out, I will have 1. If I take a 6 out, I will have 2 sine square x. Right, and I'm going to use my double angle formula for my cosine. So my cosine double angle formula. Right, remember the cosine comes in 3 different flavors. Right, so I'm going to utilize the second flavor, or actually, sorry, the third flavor. So I'm going to utilize cosine 2u, or I'm going to use x in this case, equals 1 minus 2 sine squared x. And that's exactly what I'm going to do. Instead of writing it down like this, which I have right here, I'm going to write it down like this, which is now going to be 6 times cosine 2x. So my final answer, 6 cosine 2x. That's it. Pretty simple, huh? Okay, and the last one, 26. 26 is cosine x plus sine x times cosine x minus sine x. Right? This one, you're going to have to do a multiplication of it or a distributed property, however you want to choose. And you will get, so if you do area model, cosine x sine x plus cosine x minus sine x, you will end up with cosine square x. You will end up with, I'll put in red, positive cosine x sine x. And I'll put this one in red also, negative cosine x sine x. And back here, you will end up with negative sine square x. Okay, these right here are going to cancel because they're going to be opposite. So what am I going to get? I'm going to get a cosine squared x minus sine square x. Let me move this out of the way. Okay, and then that's going to give me, and this is going to utilize my my double angle formula. And if you look at your double angle formula for the cosine 2u, that's the very first one. So this is equal to cosine 2x. Okay, and we're done. All right, guys, that's a wrap. And that's the end of the class, or in the summer period. See you tomorrow.